Okay, let's continue. So this question, what is that? Find a B and C such that this vector and this vector are collinear. You see, if you multiply by 7 by 3, you'll get 21. Or if you divide 21 by 3, you will get 7. Therefore, if you divide this one by 3, you have to get to this, right? So 6 divided by 3 is what? 2. Also, this one I said multiply by 3, right? Negative 2 multiplied by 3 is? Negative 2 multiplied is going to be what? Negative 6. Therefore, I know the B should be 2 and C here should be negative 6. Two vectors are collinear if they are multiple of each other. So now vector addition. So if this is the U1, U2, U3, V is V1, V2, V3, when you add them, you simply add their X components. So it's going to be U1 plus V1, U2 plus V2 for Y component, U3 plus V3. So vector subtraction, again, going to be the same thing, right? If the U is again U1, U2, so yeah, U1, U2, U3, V1, V2, V3. So if you want to do U minus V, of course you need to subtract the X component. U1 minus V1. U2 minus V2. U3 minus V3. Okay, simple. So vector between 2 points. Let's say P1 is going to be X1, Y1, Z1 component. P2 is X2, Y2, Z2. P1 minus P2 is going to be second one minus the first one, right? So it's going to be X2 minus X1, Y2 minus Y1, and Z2 minus Z1. We did have the same thing in 2D. So magnitude, we did talk about that between two vectors. So since my X, Y, and Z component of the P1, P2 is there, you know that for P1, P2, the magnitude is going to be X component power 2, which is X component of that is this, plus the Y component, Z component power 2. Okay, clear. So example 5, interpret Cartesian vectors A, B, find A, B. Okay, A, B, of course, it's going to be B minus A. It's going to be negative 1 minus 3 for X component, 0 minus 6 for Y component, 5 minus 1 for Z component. Just put this bracket closed like this. So it's going to be negative 4, negative 6, and 6. So determine the magnitude of the AB. So AB magnitude, of course, the X component power 2, we got the X, Y, and Z component over there here, right? Negative 4 power 2 plus negative 6 power 2 plus 6 power 2. Let me just calculate this one. The magnitude is square root of 88. Just going back to the previous one, I can write in a term of I and J and K, right? So it's negative 4I minus 6J hat plus 6K hat. Okay, determine the unit vector U in direction of the AB. I know the unit vector in direction of the AB gonna be AB divided by the magnitude of the AB, right? So AB is just gonna be 1 over the magnitude, which is what? 88, and AB is there. Negative 4, negative 6, and 6. If you simplify that, because this one is going to be 2 square root of 22, you can divide each term by 2, right? What do you get? It's -2, -3, and 3. You can put that in. So it's going to be 1 over square root of, I want to put that in, -2 over square root of 22, -3 over square root of 22, and 3 over square root of 22. Okay? So the next one is dot product, the same thing that we did. So you have the u and v. Dot product means x component multiplied by x component, so it's going to be u1 multiplied by v1 plus u2 multiplied by v2 plus v3 multiplied by u3 multiplied by v3.